Let's look at this question. Calculate the force in member CF. So he wants the CF. What is CF? This member CF. The force in member CF. Remember, this truss has a ruler here, reaction to the y, dy, and here a pin. So there is one reaction in the AY and one reaction in the AX. And he wants, look at this, he wants CF. So how could we do it? And he wants by the joint method. Still, this is still joint. It's not section, it's joint. Now let's do a free body diagram. And as we said here, we should ignore the inside. Okay? There is a 4 kilonewton here and 2 kilonewton here, and then dy here and ay, and let's ax is equal to 0 because there is no forces in the x-axis, so ax is equal to 0. Okay? So the best here, is it to find summation of force at y equal to 0? No, because dy plus ay, and there's 2 minus 4 minus 2, and there is 2 unknowns in one equation. Let's do summation of moment. Let's take moment at a equal to 0. So this force will pull the truss positive, dy times 2, 2, 2, 6. So dy times 6. See that? This force, 4 will pull the truss negative, clockwise. 4 times 2, and there's another 2. So minus 4 times what? Summation moment at a equal to 0. So minus 2 times 2 and minus 4 times 4. So this is wrong here. So that's not 2, that's 4. Minus 4, you can see 2, 2. Minus 4, this is going to push it in the minus 4 times 4. So this is not 2, that's 4. And also minus 2, it will pull it like that, 2. So minus 2 times 2 and minus 4 times 4 plus dy, and this would give you the reaction dy. So I'm going to go ahead and assume it is, let me just find out here. Let me just do my calculation. Yeah. So if you look at this question, you can see even though that he put 2, but the answer is correct. Just do it like this. Minus 2 times 2, minus 4 times 4, plus dy times 6, and that answer would be dy equal 3.33 kilonewton. Okay, so we found dy. We could find ay by doing summation of forces at the y equal to 0, so you could find ay easy. So summation of force at y equal to 0, you could find ay 2.67 kilonewton by applying the method of all the forces in the on the y-axis equal to 0. Now, let's apply the method of joints. Okay? So let's take joint, since he want CF. If you want CF, which joint do you want to take? You should start from something. Here you have 2 reactions, here you have 1 reaction. Let's start from joint D. And we could work it out until this force. Okay? So let's start from joint D. Joint D, we have 2 forces, FCD and FDE, and there is a force at the y, dy equal 3.33. Now, let's find FCD by applying, remember, this is in the x-axis, let's do summation of forces at the y. And remember, in the joint method, there is no summation of moment, only summation of moment to find the reaction. But for the joint, once you apply joint, there is no moment, either summation of force at the y equal to 0 or summation of force at x equal to 0. For this one, to find FCD, you do summation of force at the y. So you do it like this. FCD cosine 45, FCD sine 45 in the y. So FCD sine 45. And then plus 3.33 equal to 0, you could find FCD. And summation of force at x equal to 0. Now we have FCD cosine 45. And that's negative. And if you have FDE in the negative, of course we have to assume it both tension and then FCD is negative, which means it's compression. So FCD was assumed tension, but it's negative. Now it's the opposite side, it's compression. Okay, same thing for FDE. It happened to be plus. So our assumption for FDE is tension. Now let's go to the next joint. We found joint D. Now let's go to joint E. Joint E, if you look at it, there is one force here, and we just found it just now, and it's tension. And of course, tension here should be tension at the same point. Okay, we have one force here and we have one force here. Let's put joint E in the picture. Joint E, there is one force up FCE, and there's one force to the right FEF, and there's one force to the left FED 3.33. Again, it's tension. Now, let's do summation of forces at the y equal to 0. Remember, this is when he said that there is a 0 member truss. If you do summation of forces at the y equal to 0, you can see that this is an x, this is an x. This one has nothing in the y except it, which means that FCE is equal to 0. This is the way that you should look at joints. And this is one way of saying that FCE, for sure it's 0 because there is nothing in the y-axis but FCE. So summation of force at y equal to 0, FCE is equal to 0. This is what we call a zero force member. Although it does not support any force, it is necessary to avoid bulking or buckling. Okay? And sometimes we have forces, and these forces will not carry any loads. It's only good for buckling. Now, let's find summation of force at the y equal to 0. Remember, we have this force. We could do it. This is in the negative, and this is in the plus. So FEF is 3.33. Now, we have FEF. Remember now, we have this, we have this, we have this. We need this. So what's next? FC, joint F, that's gonna make it very bad. Or joint C, which one is the best? Let's look. Let's take joint C. Joint C, because we have this force is equal to 0, and we need to find this force, FCF. And we have this joint, this force, and it is compression. Remember, let's go back. Joint C, we have this force, 4 kilonewton. We have this force, tension, assumed tension. We have this force, tension. And we have this force, 0. We just showed it. And we have this force, and we just found it. It's compression. So it's going to push point C. It's not going to pull. It's going to push. So let's put joint C by itself. See? Compression. We have the angles. So to find FCF, what's the best way? To find FCF, the best is not to find summation of force at X, because this is unknown. And we don't need FPC. The best is to find summation of force at Y equal to 0, because we could find this. This is known, and this is 0, so we could find this easily. We have the angles. So let's find summation of force at Y equal to 0. Look at this. In the negative, FCF cosine 45, negative. And this is 4.71 cosine 45, also negative, which means this one gonna be negative, this C. Okay, this is negative, or what? Minus FCF and 475 cosine 45. This is, it's going negative. Wow. This is in the Y. Oh, again, I'm so sorry. We look at the y. So this is cosine 45, sine 45 negative, FCF. See? And this one, cosine 45 in the x, sine 45 as going up in the y. So that's why 471 sine 45. So FCF is positive, it's tension. So FCF is tension. Do you want to find summation force of the x? You could do that, but it is not needed. But you can see here it's negative, so it's compression. So you could do this as an example for you. So now we found this one.